This is a previous year ISRO question. The difference between a named pipe and a regular file in Unix is that option A, unlike a regular file, named pipe is a special file. This is true. Named pipe is a special instance of a file that has no contents on the file system. Option B, the data in a pipe is transient, unlike the contents of a regular file. This is also true. A FIFO special file, also a named pipe, is similar to a pipe except that it is accessed as a part of the file system. It can be opened by multiple processes for reading or writing. When processes are exchanging data via the FIFO, the kernel passes all data internally without writing it to the file system. Thus, the FIFO special file has no contents on the file system. The file system entry merely serves as a reference point so that processes can access the pipe using a name in the file system. Now, option C. Pipes forbid random accessing while regular files do allow this. The kernel maintains exactly one pipe for each FIFO special file that is opened at least by one process. The FIFO must be opened at both ends before data can be passed, normally opening the FIFO blocks until the other end is also opened. So, pipes are forbidding from random accessing while regular files do allow this. So, option A, B and C are all correct. So, D, option D, all of the above is the correct answer. This is a previous year ISRO question. A class with 30 students occupy a classroom containing 5 rows of seats with 8 seats in each row. If the student seats themselves at random, the probability that the 6th seat in the 5th row will be empty is what? And options are given. So, as part of step 1, we are given 5 rows with 8 columns. So, total number of seats. Total seats are 5 into 8, which is equal to 40. Now, the number of students. Total number of students. Total students are 30. Now, there's a constraint given that the 6th seat in the 5th row is empty. So, based on that constraint, the total available seats for the students to sit are total seat based on the above constraint, is equal to 39. So, the total number of choices that a student has to sit based on the constraint is 39C 30. And the total possible combinations are 40C 30. So the probability would be 39C 30 divided by 40C 30. This is the total number of seats based on the constraint, and this is the total number of seats without the constraint. So solving this, we will be getting 39 factorial divided by 30 factorial into 9 factorial. This is based on the formula NCR is equal to n factorial by r factorial into n minus r the whole factorial. Here n is 39 and r is 30. So similarly, we'll be getting here 40 factorial divided by 10 factorial into 30 factorial. Solving this again, we'll be getting 39 factorial divided by 30 factorial into 9 factorial into 30 factorial into 10 factorial divided by 40 factorial. So we can rewrite this as 39 factorial by 30 factorial into 9 factorial into 30 factorial into 10 factorial can be written as 9 factorial into 10. So 40 factorial can be written as 39 factorial into 40. So cutting all those things, 39 factorial and 39 factorial, 30 factorial into 9 factorial will be cut as 30 factorial and 9 factorial can be cut. So 10 by 40, we have 1 by 4. So option C, 1 by 4 is the correct answer here. This is a question from engineering mathematics. The domain of the function log of sine x is, and four options are given. So the first point to note is that sine x is the function having range between -1 and 1. So sine x ranges between -1 and 1. Log of x is defined only when x is positive and greater than 0. Log of x is defined when x is positive and greater than 0. So log of sine x, this is first we are taking, is defined only when 0 less than sine x less than or equal to 1. Then range would be minus infinity to 0. Now log of sine x is undefined as logarithm for non-positive numbers isn't defined for real numbers. Hence, domain of log of sine x is an empty set. So option C is the correct answer. This is a previous year ISRO question. The following paradigm can be used to find the solution of the problem in minimum time. Given a set of non-negative integer and a value k, determine if there is a subset of the given set with sum equal to k. So the above problem is clearly specifying the subset sum problem. The sum of the subset problem can be solved using recursion or using dynamic programming. If it is solved using recursion, the time complexity would be an exponential time of the order of 2 to the power n, where n represents the total number of elements in the array. So if it is solved using dynamic programming, it can be solved within the time of order of n into k, where k is the specific sum that is required. So this is a classic example of a solution using dynamic programming. So option B is the correct answer here. This is a question from discrete mathematics. G comma star is an abelian group. Then four options are given. Let's see each option one by one. Option A, x is equal to x inverse for any x belonging to G. This is false because if every element in the group is in its own inverse, which means that x equal to x inverse for every x belonging to G. This means that G is abelian, but the converse is not true. Consider Z, plus is an infinite abelian group, but the following are not true for it. E is equal to 0 and x equal to x inverse is not true because inverse of 1 is not equal to 1 but minus 1. So option A is not the correct answer. Let's see option B. X is equal to x square for any x belonging to G. False because 1 square is equal to 1 plus 1 is not equal to 1 but 2 here. So this option is also not correct. Let's see next option. Option C. X star y the whole square is equal to x square star y square for any x belonging to G. This is true because G is an abelian group if and only if x comma y the whole square is equal to x square y square for all x comma y belonging to G. This implies that x comma y belongs to G. So x comma y the whole square is equal to xy into xy, which implies it's equal to xx comma yy. Since G is abelian and commutative property holds, so we can rewrite this as x square into y square. So as a result, one side of the property holds. Let's see the other side, that is xy the whole square is equal to x square y square for all x comma y belongs to G. Then we can have the following, that is x comma y the whole square is equal to x square y square, which is equal to xy which is equal to xx yy x inverse xy which is equal to xx yxy which can be rewritten as xyy xyy inverse which can be written as xyy inverse yx which is again equal to xy. So the property that option 3 is also correct. Option D, this is also false because z comma plus is an infinite abelian group, is an infinite abelian group. So option D is also not correct. So based on the options, option C is the correct answer. This is a programming question. Consider the following C code segment, and a C code segment is given. For the program fragment above, which of the following statements about the variables I and j must be true after execution of the program, where exclamatory marks represents the factorial. So we are asked to find out what are the values of I and j if the program executes. So one thing that can be sure by looking into the code is that once the whole program is complete, the I value will be equal to 10 as I is incremented each time, and when when I is less than 10 only, the whole code terminates. The second point is that j is equal to j into I. So at each iteration j will be multiplied by with the current I value. So in each iteration initially j will be 1, next iteration j will be equal to 1 into 2, and in the next iteration j will be equal to 1 into 2 into 3. Similarly this goes on till j is equal to 1 into 2 into 3 into 4 etc into 9, because in the when I is equal to 10 the whole loop stops. So when I is equal to 10, j will be equal to 9 factorial. Just read the options here. So option based on option A, this cannot be correct, but option B can be correct, option C will not be correct, and option D can also be correct. Now move on to the next thing. So we have two options as of now, B and D. Now one more point to note here is that if x equal to I, we break. So what happens here is that the ultimate value of I can also be equal to x. I can be equal to x. Now when I is equal to x, this similarly this j value will be also following a pattern where j will be equal to x minus 1 factorial. So going by the options, option D is the correct answer here. That is when j equal to 9 factorial, I will be equal to 10, or when j is equal to x minus 1 factorial, I will be equal to x. So option D is the correct answer. This is a question from Digital Logic Design. A computer uses ternary system instead of the traditional binary system. An n-bit string in the binary system will occupy, and 4 options are given. So let's solve this question. First of all, the maximum number in binary with n bit is equal to 2 to the power n minus 1. Similarly, maximum number in ternary with x bit is equal to 3 to the power x minus 1. Both will take different number of bits to represent the same number. So we can equate it as follows. 3 to the power x minus 1 is equal to 2 to the power n minus 1. Solving 3 to the power x equal to 2 to the power n. Taking log to the base 3 on both sides. We have x into log 3 base 3 equal to n into log 2 to the base 3. We have x is equal to n log 2 to the base 3. So going by the option D is the correct answer. This is a question from data structures. Which of the following is the application of breadth first search on a graph? So breadth first search on a graph is a graph traversal technique in which we are given a starting node and we traverse the nodes in the graph breadthwise. It uses Q data structure. So finding the diameter of a graph and finding bipartite graph are both the application of breadth first search of a graph. So option C, both A and B are the correct answer. So some of the other applications of BFS includes finding there is a cycle or not. Also single source shortest path in a given unweighted graph can also be found out using breadth first search. So these are some of the examples. This is a question from computer organization. A microprogram is, and four options are given. So first of all, what is a microprogram? A microprogram is basically a microcode to program a microprocessor. It is a low-level language typically consisting of machine language instructions that are stored in ROM. It is a sequence of micro instructions. Therefore, microprogram is a set of micro instructions that define the individual operations in response to the machine language instruction. So option B is the correct answer here. This is a question from algorithms. Given two sorted lists of size m and n respectively, the number of comparisons needed in the worst case by the merge sort algorithm will be, and four options are given. So merge sort algorithm uses divide and conquer technique. Here we divide both our list into m and n single element lists respectively. Now we know that first m lists are sorted and after this next m list will be sorted, then the n lists are also sorted. So this is a memory based question. So in the worst case, what will be the total number of comparisons needed would be m plus n minus 1. So option D is the correct answer. This is a software engineering question. In unit testing of a module, it is found out that for a set of test data, at the maximum 90% of the code alone were tested with the probability of success 0.9. The reliability of the module is what? And four options are given. Here, the important point to note here that at the max 90% of code is tested. This point is important. Also given probability of success. Probability of success is equal to 0.9. Now reliability is equal to 0.9 into 0.9. This 90% is converted into 0.9 here, and this is the probability of success. So it is 0.81. Now answer is at most 0.81, option C, because we are given that maximum 90% of the code was tested. So maximum means at most 0.81 would be the answer. Hence option C is the correct answer. This is a question from database. In a file which contains 1 million records and the order of the tree is 100, then what is the maximum number of nodes to be accessed if B plus tree indexing is used? So, and four options are given. Order of B plus tree is given as order of B plus tree is equal to number of pointers per node, that is number of pointers per node, which is equal to 100. This is given. So minimum number of pointers per node is equal to seal value of p by 2, that is p is equal to 100, so seal of 100 by 2, which is equal to 50. So minimum number of pointers per node is 50. Next, number of nodes in last level. is equal to 10 to the power of 6, which is equal to 1 million divided by the number of pointers per node. That is the minimum number. So which is equal to 2 into 10 to the power of 4. Now number of nodes in second last level, which is equal to 2 into 10 to the power of 4 by 50, which is equal to 400. Next, number of nodes in third last level, which is equal to 400 by 50, which is equal to 8. At last, number of nodes in fourth last level, which is equal to 8 by 50. We can rewrite it as 1. So the maximum number of nodes that is to be accessed equal to number of pointers in the B plus tree level. So here there are 4 levels. So the correct option is option 4, and option B is the correct answer here. This is a question from operating system. A particular disk unit uses a bit string to record the occupancy or vacancy of its tracks, with 0 denoting vacant and 1 for occupied. A 32-bit segment of this string has hexadecimal value D for FE2003. The percentage of occupied tracks for the corresponding part of the disk is to the nearest percentage. So let's write the hexadecimal value D for FE2003, and the equivalent binary is D will be 1101, 4 will be 0100, F is 1111, E is 1110, 2 is 0010, 0 will be 0000, and next 0 is 0000, and 3 is 0011. Now let's calculate the number of ones. Here we have 1, 2, 3, 4, next 4, so 8, 9, 10, 11, 12, 13 and 14. So number of occupied tracks equal to 14, and number of vacant tracks is equal to 32 minus 14, which is equal to 18. So percentage of occupied tracks is equal to 14 by 14 plus 18, which is approximately 43.75 percentage. So mapping it to the nearest percentage will be having 44 percentage. So option D is the correct answer. 32-bit segment. This is a question which is related to DBMS. Which of the following is dense index? And 4 options are given. So first of all, what is dense index? In a dense index, there is an index record for every search key value in the database. This is what dense index is. Now moving on to options. Option A, primary index. In primary index, an index is maintained for anchor value of the block. That is, one key value per block is maintained in the index file. So this is not dense index. Second one is cluster index. In cluster indexing, it is basically a mixed sort of indexing. That is, it is dense as it is maintained for unique values and sparse as it is not maintained for every value. So we cannot say this is completely a dense indexing. Option C, secondary indexing. In secondary indexing, it is actually a dense form of index because for every key value pair, we are maintaining an index entry. So option C, secondary index is the correct answer. This is a question from database. In ER model, Y is the dominant entity and X is a subordinate entity, and four options are given. So the basic idea is that if Y is a dominant entity and X is a subordinate entity, that means that existence of X depends on existence of Y. In other words, deletion of Y will cause deletion of X. This is the property to remember. Now going by the options, if X is deleted, then Y is also deleted. False. If Y is deleted, then X is also deleted. True. Going by the intuition of dominant entity and subordinate entity, if Y being a dominant entity, it is deleted, then X should also be deleted. So option B is the correct answer. This is a question from computer organization. Of the following, which best characterizes computers that use memory mapped IO? So first of all, what is memory mapped IO? Memory mapped IO uses the same address space to address both memory as well as IO devices. The memory and the registers of the IO devices are mapped to address values. So when an address is accessed by the CPU, it may either refer to a portion of the physical RAM or it can also instead refer to the memory of an IO device. Thus, the CPU instructions can be used to access both the memory as well as accessing the IO devices. This is the basic concept of memory mapped IO. And going by the options, we can see that the computer provides special instructions for manipulating IO ports. No, this is not true. Option B. IO ports are placed at addresses on the bus and are accessed just like other memory locations. Yes, this is true. In memory mapped IO, some of the addresses are assigned to IO. So whenever the addresses are placed, we refer to those memory locations. So option B is the correct answer here. This is a question from algorithms. Of the following sorting algorithms, which has a running time that is least dependent on the initial ordering of the input? Let's see the options. First of all, insertion sort. Insertion sort. In insertion sort, if the array is already sorted, then it takes order of n time only. But if the array is reverse order, then it will take order of n square. So this is already sorted. This is reverse order. So this cannot be true. Now in quicksort, if the array is already sorted, then it would take order of n square time, the worst case time complexity, already sorted. So this is also not the correct option. In selection sort, for any case, it would take order of n square only, but the number of swappings will be less if the array is already sorted. So less number of swaps, less swap on sorted array. Now option A, merge sort. For merge sort, the time complexity is order of n log n at any case. Merge sort has order of n log n time complexity at any case. So it is least affected by the ordering of the input sequence. And going by the options, option A, merge sort is the correct answer here. This is a question from operating system. Processes P1 and P2 have a producer-consumer relationship, communicating by the use of a set of shared buffers. So P1 is given as, this is in a while loop. So obtain an empty buffer, fill it, return a full buffer, and we repeat it. For P2, obtain a full buffer, empty it, return an empty buffer, and this is continuing. So this can be considered as a producer, and this can be considered as consumer. So this is a producer-consumer relation. Increasing the number of buffers is likely to do what of the following? 1. Increase the rate at which the requests are satisfied, that is throughput. 2. Decrease the likelihood of deadlock. 3. Increase the ease of achieving a correct implementation. So, first of all, increasing the size of memory or buffer to the allocated process is simply allowing it to increase the rate at which requests can be satisfied. Yes, this is true. Second option, decrease the likelihood of a deadlock. Increasing the buffers does not deal with decreasing the likelihood of deadlock. So option 2 is not correct. Increasing the ease of achieving a correct implementation. This is also not correct because even if you increase the buffers, the ease of achieving correct implementation is not at all related to increasing the size of the buffer. So going by the options, only option 1 that is correct, and here C 1 only is the correct answer. This is a question from data structures. A doubly linked list is declared as struct node int value, and there are two pointers FWD and BWD. They represents the forward and the backward link to the adjacent elements of the list. Which of the following segments of code deletes the node pointed to by X from the doubly linked list if it is assumed that X points to neither the first nor the last node of the list? So here we are asked to find out the code which can delete a node that is not the first nor the last of a doubly linked list, and four options are given. Let's see each of the options. Now moving on to option A. Option A is given as X backward forward is equal to X forward, and second point is X forward backward is equal to X backward. Let's construct a doubly linked list with four nodes. So this is node 1. This is node 1. The initial address here would be null. Here let's assume the value as A, and this is the forward list of this. This will be pointing to the next node. This will contain B, and this will be pointing back to here. This will be pointing to the next node C, and finally the final node D. This will be having value null, and this will be the backward pointer. This will be the backward pointer. So this is how the doubly linked list would look like. Now suppose this is the node X. Now X backward means we are pointing to here. We'll reach X backward means we'll reach this particular node, and the forward would be this point. This point, what will happen? We are trying to make it point to X forward. X forward means this node. So from here we'll be pointing to directly this node. So ideally this connection would be lost. The next point is X. So now we are executing this one. X forward means from here we'll reach here, the backward. So this would ideally point to X backward. X backward means this. So this would be pointing from here to here. So this pointer would be deleted. So ideally there is no connection between these two. So this node would get deleted. So the node B would get deleted. So option A would be the correct answer here. Option A is the correct answer. This is a question from data structures. If tree 1 and tree 2 are indicated below, which traversals of tree 1 and tree 2 respectively will produce the same sequence? And the orders are pre-order, post-order and in-order. So the important points to note here is that in pre-order traversal, what we do is in pre-order, we print the root, then we traverse to root left, then root right. This happens recursively. In post order, what happens is we move to root left, then we move to root right, then we print root. In order, we move to root left, we print root Then we move to root right. The movement of root left and root right happens recursively. This is the basic concept. Now let's see the traversals of each type for the trees. Now for tree 1, let's see the pre-order. Tree 1. Pre-order. In pre-order traversal, we initially print the root. So this A gets printed. A gets printed. Then we move to roots left. So then when we reach here, we have root here. Now the root is this. So B gets printed. Then we move to roots left. It is not there. So we move to roots right. So we print D. Then we move to roots left. So we print E. We move to roots left. We print G. Now we are here. There is no left and right. So we trace back and we reach here. Now we move to roots right. Now we reach here H. So we print H. Then we move to roots left. It is not there. Then we move to roots right. We print I. Then again we move to roots left. It is not there. We move to roots right. J. Now we don't have any left or right. So iteratively trace back to here, back to here, back to here. Then we reach here. Now we move to roots right. That is F. Then we iteratively move back, move back, move back, and we move to roots right. So we print C. This is what happens in pre-order traversal. Now we see what is the in-order traversal. In order. In in-order traversal, we first move to roots left. So we reach here. Now there is no left, so we came back and we print B. Now we move to roots right. Then we move to roots left. Iteratively move to roots left. Now since there is no left and right, we print G. Then we come back and we print roots right. We do not print, we recursively move to roots right. Now we move to roots left. It is not there, so we come back and print H. Now we reach here and move to roots right. We reach I. Since there is no roots left, we iteratively print I. Then we go back to roots right. Here there is no left and right, so we print J. Now we come back to here, to here, to here. Then we go back to here. Now there is no roots left, so we print D. Now we move to roots right. We reach here, there is no left, no right, so we print F here. Now we iteratively move back, and we reach here. Now this subtree has been fully traversed. Now we print A, then we move to roots right and we print C. This is the in-order traversal. Next, we consider the post-order traversal for this tree. Post-order. In post-order traversal, we initially move to roots left, then we move to roots right, then we print the root. So the root of the tree gets printed at last only. So we move to roots left here. Then there is no left here, so we move to roots right. We move to roots left. We move to roots left. Now there is no left and right, so we print G. Now we come back here. We move to roots right, roots right, roots right. So there is no left and right, so we print J here. We come back. Now there is no left and right, so we print I here. Then again we come back. We print H. Then again we come back. Now all the left and right subtree has been traversed, so we print E. Now we come back and we move to roots right. We move to F. There is no left and right, so we print F. Once we come back, this D is the root now. Its left and right has been completely traversed, so we print D. Now we come back to B. This root's left and right has been completely traversed, so we print B. Now we come back, we reach A, we move to A's right, so we print C, then we print A. This is the post order traversal. Now let's see these trees. This tree twos traversals. Tree 2. So in this similarly explained detailed manner, we can also see this. So I'm outrightly writing the traversals. So in pre-order, what happens is we print G, then there is no left, so we move to right. In right we encounter F, then we move to left of F, we reach E, then we move to left of E, we reach I, then we move left, we reach J. Once we reach J, we trace back to I, then we move to its right, so we print H. Now we trace back and we print E is here, F is here. Now we directly print this roots right, so we print C, then we print D, then we print B, then we trace back and we reach here, then we print A. So this is the pre-order traversal. Now for the in-order traversal. In order traversal, we first try to move to roots left. There is no roots left, so we print G first. Then we move to roots right, so we iteratively reach here, and we print J. Now we come back and we print I, then we move to roots right, and there is no left and right, so we print H. We iteratively come back and we print E, and we iteratively come back and we print F. Now we move to F's right subtree, that is this part. We move to C, we move to D, we move to B. Now we print B, then we come back and we print D, come back and print C, then come to roots right and we print A, then come back and we print. There is no more to print, so we iteratively come back and we reach G. Now in post order traversal, what happens here is we move to roots right first. We move to roots left iteratively. There is no left, so initially we print. There is no roots left, so we move to roots right. Then from here we reach here, then iteratively we'll reach this J first. Then we'll come back and we'll print. We reach here, then we print H. Then we come back and we print I. Then we go to E. Then we come back and move to this point. From here we move to roots left. Iteratively we'll reach here. We'll print B. Then we'll print D. Then we'll move to here C. Then we'll move to C's right, that is A. Then we come back and we print C. Then we come back and we print F. Then ultimately we print G. These are the two traversals. Now when we see the options, none of the options are matching with the options. So pre-order and post-order is not matching. Post-order and in-order is also not matching. Post-order and pre-order is also not matching. In-order and pre-order is also not matching. So actually none of the options matches. None of the options matches. This is a question from digital logic design. In the diagram above, the NOT gate and gates labeled 1 and 2 have delays of 9, 10 and 12 nanoseconds. Wire delays are negligible. For certain values of A and C, together with certain transition of B, a glitch or a spurious output is generated for a short time, after which the output assumes its correct value. The duration of the glitch is, and 4 options are given. So first of all, inverter and first NAND gate, that is 1, will take a total time of 9 plus 10 nanoseconds to perform its operation due to the delay. Then The second AND gate will take time of 2, will take 12 nanoseconds time to perform its operation. So the glitch is generated for some time just before the final output. So before operating the OR gate, it will take 19 minus 12 equal to 7 nanoseconds of spurious output would be there. After this only, the OR operation will be performing normally. So this is the glitch. So for 7 nanoseconds is the duration. So option A is the correct answer. This is a question from compiler design. Which of the following comparisons between static and dynamic type checking is incorrect? So first of all, what is a static type checking? A language is said to be statically typed if the type of a variable is known at compile time than instead of runtime. So some common examples include C, C++, etc. are static typed. Now, what is dynamic type checking? In dynamic type checking, it is the process of verifying the type safety of a program at runtime. So PHP, Python are some common examples of dynamic type check. And dynamic type checking offers more flexibility to the programmers at the expense of runtime type checking overhead and possible runtime type errors. So going by the options we have, let's see. First option A, dynamic checking slows down the execution. This is true because we are checking it during the runtime. So this option is correct. Second option, dynamic type checking offers more flexibility to the programmers. Yes, this is also true. In contrast to static type checking, dynamic type checking may cause failure in runtime due to type errors. Yes, this is also correct. Option D. Unlike static type checking, dynamic type checking is done during compilation. This is false. By the definition of dynamic type checking, it is done during runtime. And the question is asking us to find out the incorrect option. So option D is the incorrect option. So as a result, it is the correct answer. This is a question from computer networks. Dash can detect burst errors of length less than or equal to the degree of the polynomial and detect burst errors that affect odd number of bits. And four options are given. Option A, Hamming code. Option B, CRC. Option C, BRC. And option D, none of the above. So the correct answer to this question is option B, CRC. Let's see some of the properties of CRC. CRC stands for Cyclic Redundancy Check. In CRC, all burst errors of length equal to the polynomial's degree can be detected. All burst errors affecting an odd number of bits are detected. Burst errors of length greater than the degree of the polynomial are also detected with high probability. So 32-bit CRC is used in Ethernet, token ring, etc. So option B, CRC is the correct answer here. This is a question from computer networks. Station A uses 32-byte packets to transmit messages to station B using a sliding window protocol. The round trip delay between A and B is 80 milliseconds and the bottleneck bandwidth on the path between A and B is 120 kilobits per second. What should be the optimal window size that A should use? So the given data here are round trip time RTT is equal to 80 milliseconds. So the propagation delay Tp can be calculated as follows. Tp is equal to propagation delay. This is equal to 2Tp is equal to RTT. So we have 2 we have Tp equal to 80 by 2 which is equal to 40 milliseconds as the propagation delay. Now packet size which is L is equal to 32 bytes. So we are converting it into bits, 32 into 8 bits. Then we have bandwidth. Bandwidth is equal to 128 into 10 to the power of 3 bits per second. Now let's calculate the transmission delay. Tt is equal to L by bandwidth which is equal to 32 into 8 divided by 128 into 10 to the power of 3. So this 10 to the power of 3, if it goes up, it will become 10 to the power of minus 3 and we'll get milliseconds. So calculating tt is equal to 2 milliseconds here. Now efficiency is calculated as eta is equal to n, which represents the window size, into tt by tt plus 2 tp. For maximum efficiency, the window size has to be n, and to get the maximum efficiency it should be 1. So efficiency is 1. So the window size can be calculated as n into tt by tt plus 2 tp. Now we can rewrite it as tt plus 2 tp divided by tt is equal to n. Rewriting 1 plus 2 tp by tt is equal to n. Now we have 2 tp by tt is equal to 1 plus 80 by 2, which is equal to 41. This is the window size. And going by the options, we have option A 20, option B 40, option C 160, and option D 320. The closest option is option B 40, and it is the correct answer here. This is a question from computer networks. Assuming that for a given network layer implementation, connection establishment overhead is 100 bytes and the disconnection overhead is 28 bytes. What would be the minimum size of the packet the transport layer needs to keep up if it wishes to implement a datagram service above the network that needs to keep its overhead to a minimum of 12.5%? Ignore the transport layer overhead, and 4 options are given. So let's see the data. Suppose size of the datagram payload is X. Size of datagram payload is X bytes. X bytes. Connection establishment overhead. Connection establishment. It takes an overhead of 100 bytes. Similarly, disconnection overhead. It takes how many bytes? 28 bytes. And the minimum overhead that it wants to keep is 12.5%. So total overhead is equal to 100 plus 28, which is equal to 128 bytes. Now, since transport layer wants to keep a minimum overhead of 12.5%, let's calculate. 12.5% of X would be 128 bytes. So we can rewrite it as 12.5 by 100 into X is equal to 128 bytes. So rewriting X is equal to 128 into 100 divided by 12.5, which is equal to 1024 bytes. And let's see the options. Option D, 1024 bytes, is the correct answer here. This is a question from network security. In cryptography, the following uses transposition cipher and the keyword is given as layer. Encrypt the following message and spaces are omitted during encryption. Welcome to network security. And 4 options are given. So first of all, let's see how to do this encryption. Write the plain text in rows of width based on the length of the key, and we then read it off by columns. And the order of reading by columns is based on the lexicographic sorting of the key. So first of all, let's find the keyword. The keyword given is layer, L-A-Y-E-R. So we have 5 columns. And the order of reading is based on the lexicographic sorting order. So A will be the first priority. The second priority would be E. The third priority would be for L. Fourth priority would be for R. And fifth priority will be for Y. Now let's write it the plain text row by row based on the column L, A, Y, E, R, and the plain text that we are asked to write is welcome to network security. So drawing of the columns, we have first of all W, E, L, C, O, M, E. Welcome to T, O. Now network N, E, T, W, O, R, K. Network security S, E, C, U, R, I, T, Y, followed by an exclamation mark. Now based on the priority, first the ciphertext would be based on top to bottom reading of the first letter, that is A. So we'll read it as top to bottom from here. So it will be E, E, T, S, I. Now second one would be E. E would be read as C, O, O, C, Y. Third one would be L. It would be read as W, M, E, K, R. Fourth one would be R. It would be read as O, N, R, U, exclamation. And fifth one would be Y. It is read as L, T, W, E, T. Now let's see the options. Going by the options, we have option B as the correct answer. Consider this question. In a particular program, it is found that 1% of the code accounts for 50% of the execution time. To code a program in C++, it takes 100 man days. Coding in assembly language is 10 times harder than coding in C++, but it runs 5 times faster. Converting an existing C++ program into an assembly language program is 4 times faster. To completely write the program in C++ and rewrite the 1% code in assembly language, if a project team needs 13 days, the team consists of how many members? Let's solve this question. It is given that 100% of work can be done in 100 days. So it means that 100% of work in 100 days. It implies that 1% of work in 1 man day. It is also told that writing the code in assembly language is 10 times harder. It means that it is 10 times more time consuming. Also, converting existing code from C++ is 4 times easier. So it is less time consuming. Therefore, considering the overall scenario, we can say that 100% of work can be done based on these two parameters. So 100 into 10, as it is 10 times more time consuming, divided by 4, because it is 4 times less harder. So we can say that it takes 250 days in total. Now 1% of work will be done in how many days? It would take 2.5 days to perform 1% of work. Now 99% of work is in C++, and rest 1% it takes for rewriting the code. 1% for rewriting. So we can say that 99 into 1 plus 1 into 2.5 days for rewriting. 1 into 2.5 for rewriting. It would give 101.5 man days. But it is mentioned that it takes 13 days to complete. It takes 13 days to complete. So we can say that it takes 101.5 man days to complete. But it is given that it takes only 13 days to complete the whole program. So we can say that 101.5 divided by 13 is equal to 8. So we have 8 programmers to do the task. And going by the options, option C is the correct answer. This is a question from compiler design. Incremental compiler is a compiler and 4 options are given. Let's understand what is an incremental compiler. An incremental compiler is a type of compiler which can compile the partial programs rather than compiling the whole program. So it means that it compiles only those portions of the source code that have been modified, and without recompiling the whole program, it can compile the additional statements of a program. So going by the options, we have option A, which is written in a language that is different from the source language. No, this is not the answer. Option B, compiles the whole source code to generate object code afresh. No, this is also not the correct answer. Option C, compiles only those portions of the source code that has been modified. Yes, this matches with the concept of incremental compiler. So option C is the correct answer. This is a question from compiler design. What does DU chain refers to? And 4 options are given. DU chains or definition use chain consist of a definition D of a variable and all the uses U reachable from that definition without any other intervening definitions. The DU chains are created by using a form of static code analysis known as data flow analysis. Knowing the DU chain for a program or a subprogram is a prerequisite for many compiler optimization, including constant propagation and common sub-expression elimination. These are some of the concepts that is associated with DU chain. So let's see the options one by one. Option A, it consists of a definition of a variable and all its uses reachable from that definition. Yes, this is correct. Option B, it is created using a form of static code analysis. This is also correct. Option C, it is a prerequisite for many compiler optimization, including constant propagation and common sub-expression elimination. This is also correct. So option D, all of the above is the correct answer here. This is a question from compiler design. Which of the following comments about Peephole optimization is true? And 4 options are given. Let's understand the concept of Peephole optimization. It is an optimization technique which is applied to small part of the code called as peep, and peephole optimization involves changing in small set of instructions to an equivalent set of instructions that gives the better performance compared to other optimization technique and are applied repeatedly. So based on the options, let's see option A. It is applied to small part of the code and applied repeatedly. True. So option A is the correct answer here. This is a question from computer organization. A byte addressable computer has a memory capacity of 2 to the power m kilobytes and can perform 2 power n operations. An instruction involves 3 operands and 1 operator. It needs a maximum of how many bits? And 4 options are given. First of all, let's calculate the memory capacity. Memory capacity here is 2 to the power m kilobytes. Converting it into bytes, we get 2 to the power m into 2 to the power 10 bytes, which is equal to 2 to the power m plus 10 bytes. This is the total memory capacity. We can assume here 1 byte equal to 1 word. So total memory capacity in words are 2 to the power m plus 10 words. Now, one memory location requires how many bits to identify itself? It requires m plus 10 bits. Now total number of total operation is equal to 2 to the power n. So number of bits to define one operation is equal to n bits. Now given the instruction has 3 operands and 1 operator, we can identify the number of bits required by the instruction as 3 into 3 operands are there. So we require m plus 10 bits for the 3 operands plus n bit for one operation. So in total, we require 3m plus n plus 30 bits. But none of the options are matching here. So option D, none of the above is the correct answer. And the answer to this particular question is 3m plus n plus 30 bits are required, but none of it is matching. This is a question from digital logic. Any set of Boolean operators that is sufficient to represent all Boolean expression is said to be complete. Which of the following is not complete? So first of all, not, and, or. These are basic gates. And NAND, NOR are universal gates. Also, one important property is that with the help of universal gates, we can construct any Boolean expression. These gates are also called functionally complete. Now, let's see the options. And followed by OR. This does not contain not. So as a result, this cannot be functionally complete. And followed by not. So this is equivalent to NAND. So this is functionally complete. Not followed by OR. So this is equivalent to NOR. Also NOR. So this is also functionally complete. So option A, and comma OR, is not functionally complete. This is a question from data structures. Consider a singly linked list of the form where f is a pointer to the first element of the linked list and L is the pointer to the last element of the linked list, the time of which of the following operations depend on length of the list. So we are given two pointers, f which point towards the first node and L which point towards the last node. So let's see options one by one. Option A, delete the last element of the list. Yes, in order to delete the last element of the list, first of all, we need to get the address of the second last element so that that can be set as null here. So outrightly we cannot get the last element address and the second last element address. Only we are having the last element address which is pointed by L. But to get the second last element's address, we need to traverse the whole length of the list. So this operation depends upon the length of the list. So option A can be an answer. So let's see all other options. Delete the first element of the list. To delete the first element of the list, all we need to do is that we need to move the pointer f towards the next node. So we just need to move the pointer towards the next node and this can be set pointing here. So this doesn't take the length of the list, it is just a constant operation. And option C, add an element after the last element of the list. Even to add an element after the last element of the list, we can know the address of the last element of the list due to this pointer L. Then we just need to append one more node here. So this can also be done in constant amount of time. This can be done by setting L of next towards the new node. This is done in constant amount of time. Interchange the first two elements of the list. Again, to interchange the first two elements of the list, this can be done using a temporary node and it does not depend upon the length of the linked list. So going by the options, option A, delete the last element of the list. It would require us to traverse the whole length of the list to know the second last element. So option A is the correct answer here. This is a question based on lexical analysis from compiler design. A particular BNF defined for a word is given by the following rules. Which of the following lexical entries can be derived from word? First one is pick. So in order to generate pick, we have starting word. Then it can generate letter followed by character pair, that is char pair. So this letter can in turn generate one of the letters from A to Z. This can generate P. Next we can see char pair can generate either two letters or a character pair followed by two letters. So in order to generate these three characters we need at least this char pair followed by letter followed by letter. Let's try to generate that. Now this char pair, it again becomes char pair. I'm denoting letter as L as of now. L followed by L. Now this char pair, I'm as of now denoting it as CH. So L and L can again generate C comma K. Now we cannot generate a single letter from char pair. So pick cannot be generated. So this cannot be generated. Next, let's try to generate picks. P-I-C-K-S. This can be generated from, let's denote word as W, letter as L, and char pair as CH. So L followed by CH. This would again generate L as P, and CH would be again CH followed by L followed by L. This would again generate CH, which can generate a letter followed by a letter and the next letter followed by letter. This would again generate P, I, C, K, S. This would be I, this would be C, this would be K, this would be S. So picks can be generated. So picks can be generated. Now let's see the next one. C44. C44. To generate C4 from W, we have letter followed by int pair. This one. Let's denote it as I for time being. I. Now this L can be generated as C, and integer pair can have integer integer. So integer integer. We can generate C44. So we can generate picks as well as C44. So picks is option 2 and C44 is option 3. So option D, 2 and 3 only is the correct answer. This is a question from network security. Avalanche effect in cryptography is, and 4 options are given. So first of all, let's understand what is avalanche effect. In cryptography, the avalanche effect is a desired effect in encryption to ensure that a person cannot easily predict a message based on the changes in the hash value through a statistical analysis. If an input is changed slightly, even flipping one single bit, the output changes significantly. So avalanche effect is a desirable property of the cryptographic algorithm. And going by the options we have, it is a desirable property, it is an undesirable property, it has no effect. So option A is a desirable property of the cryptographic algorithm is the correct answer here. This is a question from artificial intelligence. In neural network, the capacity of the network is defined as, and 4 options are given. So first of all, what is a neural network? A neural network is a network of artificial neurons that are collectively used for solving an AI problem. An example of a neural network is as follows. These are some of the input layers that the neurons have. Then there are multiple interconnections between the hidden layers. And finally, there is an output layer. This is a sample example of a neural network. This refers to the input layer where the inputs are accepted and there are multiple connections among the hidden layers. This is an example of a hidden layer, and finally it moves into the output layer based on different connections. So this is a sample neural network. So the capacity of a neural network is the total number of patterns that can be stored and recalled in a network. So going by the option C is the correct answer, and this is the input layer. This refers to the hidden layer, and this refers to the final output layer. A neural network can have multiple hidden layers also. This is a question from search engine optimization. Cloaking is a search engine optimization technique. During cloaking, what happens? And 4 options are given. Let's understand what is cloaking in search engine optimization. It is a technique in which the content presented to the search engine spider is different from the one that is presented to the user's browser. This is done by delivering content based on the IP address or the user agent HTTP header of the user requesting the page. Now, what is a web crawler or a spider? It is an internet bot that systematically browses the World Wide Web, typically for the purpose of web indexing. So based on this concept, we can say that option A, content presented to the search engine spider, is different from that is presented to the user's browser. This option A is the correct answer. This is a question from network security. What is the one advantage of setting up a demilitarized zone with two firewalls? And four options are given. Let's understand the concept of DM set. In computer networks, a DM set is a physical or logical subnetwork that separates an internal local area network from other untrusted network, usually the internet. External facing servers, resources and services are located in the DM set so that they are accessible from the internet. But the rest of the internal LAN remains unreachable. This provides an additional layer of security to the LAN as it restricts the ability of hackers to directly access internal servers and data via the internet. A more secure approach is to use two firewalls to create a DM set. The first firewall is called perimeter firewall. So the first firewall is perimeter firewall. It is configured to allow traffic destined to the DM set only. The second firewall or the internal firewall. It allows traffic from the demilitarized zone to the internal network. So based on the options, the best option which matches the concept of DM set with two firewalls is that we can control where traffic goes in the three networks. So option A is the correct answer here. This is a question from network security. Which of the following algorithm is not used in asymmetric key cryptography? So first of all, let's understand what is asymmetric key cryptography and symmetric key cryptography. In symmetric key cryptography, we use the same key for encryption and decryption. So in symmetric, same key for encryption and decryption. Whereas in asymmetric key cryptography, asymmetric we have different keys. This is the major concept. So first of all, let's see option A, RSA. RSA is a famous asymmetric key cryptographic algorithm. So it is not the answer. Option B, Diffie-Hellman. Even in Diffie-Hellman also, it uses private public key pair to establish a shared secret. So as a result, it is also a asymmetric key. Whereas electronic code block algorithm, it is the simplest and weakest form of DES. It is not used in asymmetric key cryptography. So option C, electronic code block algorithm is the correct answer. This is a question from database. Consider the following table in a relational database and four attributes are given. One is last name, the other is rank, then we have room, then we have shift. According to the data shown in the table, which of the following could be a candidate key of the table? So first of all, what is a candidate key? A candidate key must be able to uniquely determine every other attribute. So based on this definition, let's see the options. First one is last name. Using last name, can we uniquely identify the other three attributes of rank, room and shift? This is not possible because we have two value for Smith here. So if you are given the value of Smith, we cannot identify which Smith and which other attributes it refers to. It can be either here or this attribute. So this is not the correct answer. Second one is room. Even in room also we have 33 as repeating value. So using room alone as attribute or a candidate key, we cannot identify all of the attributes. So option B is also not the correct answer. Now let's see shift. Even in shift we have two morning shifts. So as a result we cannot uniquely identify. But a composite key consisting of room and shift. Let's look into this. Room and shift. So 234 comma morning, there is no repetition. So using 234 comma morning we can uniquely identify the other attributes. 33 comma afternoon. So there is no repetition of 33 comma afternoon. So this can be also uniquely identified. 33 comma evening, there is no repetition. 222 comma morning. So the composite key of room comma shift can uniquely identify every other attributes. So as a result, option D is the correct answer here. This is a question from computer organization. A data-driven machine is one that executes an instruction if the needed data is available. The physical ordering of the code listing does not dictate the course of execution. Consider the following pseudocode. A. It means that multiply E by 0.5 to get F. B. It means that add A and B to get E. C. Add B with 0.5 to get D. Now D. Add E and F to get G. E. Add A with 10.5 to get C. Now assume that A, B and C are already assigned values. So the first assumption is that A, B and C already exist. And G is the desired output. G is the desired output. Which of the following sequence of execution is valid? So one trick that we can use to get the answer quickly is that the final output that has to be get is G. Now looking through the options, which option can generate G finally? A cannot generate G. This A cannot generate. B also cannot generate G. C also cannot generate G. D also cannot generate G. Whereas G can generate G. E cannot generate G. So ultimately, in order to generate G, D should be the last step that is followed. So if you look at here, this cannot be true. 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 But this can be true. Now let's verify it. So first step is C, that is add B with 0.5. Already in our list we have A, B and C. Now we are adding B plus 0.5 to get D. Now we have D in this list. Then we follow B. B means add A and B to get E. A plus B, we get E. Now E is also in our list. Next is E. Add A with 10.5 to get C. C is already in our list. Next is option A, that is multiply E by 0.5. We have already E in our list, so E into 0.5 to get F. Now F is also in our list. And the last option D, we have add E and F. E is already in our list, F is already in our list, so E plus F will generate G. So going by the options also, option B is the correct answer. This is a question from algorithms. Assume A and B are non-zero positive integers. The following code segment, while A not equal to B, if A greater than B, A is equal to A minus B, else B equal to B minus A. See out A, that is we are printing the value of A, and four options are given. Computes the LCM of two numbers, divides the larger number by the smaller number, computes the GCD of two numbers, or finds the smaller of two numbers. Actually, this code is actually implementing the Euclidean method for calculating the GCD of two numbers. Euclidean method. Now let's take a sample to see what is happening. Assume A is equal to 2 and B is equal to 5. The GCD of these two numbers are obviously 1. Now let's calculate. Here we have the first step, A is equal to 2. So in the step 1 or the first iteration, we have A equal to 2 and B equal to 1. If A greater than B, no. Then we make B equal to B minus A. Now B is equal to B minus A means B is equal to 3 and A is equal to 2. Now in step 2, A is not equal to B. Now A greater than B, no. Again B equal to B minus A. Now B equal to 1 and A is equal to 2. Next in step 3, we have A not equal to B, but A is greater than B. So A is equal to 2 minus 1, that is 1. And B is also equal to 1. Now in step 4, A is equal to B. So we print the value of A, that is equal to 1. So GCD of 5, 2 is equal to 1. Let's See what is the LCM of these two numbers. LCM of 5 comma 2 is actually 10 because it is the least common multiple. Divides the larger number by the smaller number. If we divide 5 by 2, we get the value 2. This is also not happening. Defines the smaller of two numbers. If it is this case, then we get the answer as 2. This is also not true. So option C, computes the GCD of two numbers, is the correct answer here. Consider this question. A language with string manipulation facility uses the following operation: head and tail. Head of S returns the first character of the string S. Tail of S returns all but the first character of string S. That is, it returns every character other than the first character. Concat of S1 comma S2, it concatenates string S1 with S2. The output of the function concat head of S comma head of tail of S, where S is AC BC. So first of all, tail of S, where S is AC BC. Tail of S would return CBC. Now again, tail of tail of S. This has ABC and this would again return BC. So ultimately this part would be BC. Now head of BC would return first character of the string S, that is B. So this would essentially return B. Now head of S would return A and concatenate these two would return AB. So the correct answer is option A, AB. This is a question from theory of computation. Choose the correct statement. Statement A is equal to A power n, B power n, where n is equal to 1, 2, 3, etc. is a regular language. This is false because A power n, B power n, where n greater than or equal to 1 is a context-free language. So this option is not correct. The set B consisting of all strings made up of only A's and B's having equal number of A's and B's defines a regular language. This is also not a regular language because in order to identify equal number of A's and B's, we need at least one stack. So since it is using stack, it is a context-free language. So it is not a regular language. So this is also a context-free language. Now option C, A star B intersection B gives the set A. So A star B can take the form A B, A B, B, A B, etc. Intersection B. This would return only B. So this does not give the set A, it just gives B. So this option is also not correct. So the correct option is option D, none of the above. This is a question from theory of computation. A context-free grammar is not closed under and four options are given. So this is a memory-based question. So we need to remember which are the properties for which CFG is closed and which are the properties for which CFG is not closed. For CFG is closed under union, clean closure, and concatenation. These are some of the important properties. This is CFG is closed, and in not closed we have intersection and complement. So going by the options, CFG is not closed under, union it is closed, complementation it is not closed, clean star or clean closure, and product or concatenation. Both C and D it is closed. So the correct answer is option B. So it is better to remember some of these properties because we can easily answer a question without wasting much time. This is a question from theory of computation. The finite state machine pictured in the above figure. And what is that finite state machine does? Option A, complements a given bit pattern, find 2's complement of a given bit pattern, increments a given bit pattern by 1 and changes the sign bit. Let's see each options. So let's consider 2-bit numbers first. So initially 00 be the number. So if we have to match it with option A, then it should be complementing the given bit. So 00 should become 11. So let's see the transitions. Now we are reading from this to this, that is from left to right. So upon seeing this 0, what happens? 0, it becomes 1. So this bit becomes 1 and it reaches here. Upon seeing 1, it becomes 0 only. So 0 1. So for 0 0, it becomes 0 1. Actually, it should have been 1 1. So complements a given bit pattern is not the correct answer. Now let's move on to option B. 2's complement of a given pattern. So for 0 0, 2's complement would be 1 1 plus 1. It will be 0. It will be 0. So 2's complement would also be 0 0. So let's see what will happen. For 2's complement, similarly, the 2's complement also will be 0 1 only. So this is also not the correct answer. Now let's see increments a given bit pattern by 1 1. Assume the binary number as 1 0. Then the increment value should be 1 1 actually. Let's see. For 1 0, when it sees 0, it becomes 1 and then it reaches here. Now when it sees 1, it becomes 0 actually. So it is not incrementing the given pattern by 1 bit. So option C is also wrong. Now let's see option D. Changes the sign bit. If 0 0 is the binary string and this bit represents the sign bit, it is flipping the sign bit. So when it becomes 0 0, what happens? Actually, it becomes 0 1 here. So it is not changing the sign bit. So all the options are not correct. But in the given answer key, it was said that option C is the correct answer. This can happen only when if we change the bit from here 1 becomes 1, then the option C would be the correct answer. Based on the original question, none of the options are correct, but in the answer key, option C was given. So this C would be correct only if the transition becomes like this. This is a question from theory of computation. A context-free grammar is said to be in Chomsky normal form if all the products are of the form A derives BC or A derives A. Let G be a context-free grammar in Chomsky normal form. To derive a string of terminals of length x, the number of products to be used are, and 4 options are given. So the basic concept is any CNF takes 2x minus 1 steps to get a string of length x. Here we have n minus 1 or x minus 1 steps to generate non-terminals, and then one step each to generate the non-terminals. So if n or length x, then we have n length terminals to generate. So n more steps. In total, n minus 1 plus n is equal to 2n minus 1. Here n is same as x. So we have 2x minus 1 steps. This is the correct answer. So option A is the correct answer. Now let's see a sample example. Similar to the question. A derives BC, B derives B, C derives C. This is a CNF form. To generate BC, how many steps are needed? Initially, we need n minus 1 steps to generate the non-terminals. Here the length is 2. So we need one step to generate the non-terminals. So we have A derives BC. This step generate the non-terminal. Now we have one step each to generate the terminal. So let's generate the first terminal. B can derive B. So we write A derives B C. In the next step, C can derive small c. That is a non-terminal. So A derives BC. So here we have 3 steps for a string of length 2. So we have 2 into 2 minus 1, which is equal to 3. So 2x minus 1 is the correct answer here. This is a question from database. For a database relation R with 4 attributes A, B, C, D, where the domains of A, B, C, and D include only atomic values. Only the following functional dependencies holds, and those that can be inferred from them are A derives C and B derives D. The relation is in and options are given. So first of all, let's find out the candidate key. Candidate key. We have two dependencies. A derives C and B derives D. So the candidate key of this particular relation is AC. Sorry, AB. So using AB only, we can derive all the attributes. So as a result, AB is the candidate key and A and B are prime attributes. So here there is a dependency from A derives C, as well as there is a dependency from B derives D. The dependency is such that there is a prime attribute and this is non-prime attribute. So there is a partial dependency. Similarly, in this case also, from prime attribute to non-prime attribute, there is a partial dependency. So as a result, it is not in 2NF because 2NF does not allow partial dependency, but it is in first normal form because it is in atomic value. So since it is not in 2NF, it is not in 3NF also. So the option A, first normal form but not in second normal form, is the correct answer. This is a question from databases. Consider the set of relations given below and the SQL query that follows. We have a students table, courses table, and grades table. Select distinct name from students, courses, and grades, where student roll number equal to grades roll number, and course instructor is equal to Sriram, and course.course number equal to grades.course number, and grades.grade equal to A. What is the set that is computed by the above query? Here, one important point is the instructor of the course, that is course.instructor, is equal to Sriram. So this query will return only those set of courses that are taught by the instructor Sriram. So based on that, option B can be outrightly eliminated. Let's see the other options. The other predicates will give name of students who are scoring at least an A grade. So that is one option we have. At least one A grade. And combining these two, so at least one A grade and the courses are to be taught by Sriram. So based on that, we can say that name of students who got an A grade in at least one of the courses taught by Sriram, that is option C. This would be the correct answer. This is a question from C programming. We are given a C code and we are asked to assume the required header files are already included in the program, and we are asked to find out what is the output. So we are given three functions: int A, int B, and int C. And there is a main function also. So some important points to remember here is that temporaries cannot be bound to a non-constant reference. This is an important point to answer this question. The point is temporaries cannot be bound to a non-constant reference. This means that we cannot write int ampersand set is equal to 12. This is wrong because 12 is temporary. A temporary object of type int is created from the integral literal 12. But temporary cannot be bound to a non-constant reference, hence this is error. This is not correct. But this declaration int y, int ampersand r is equal to y. This is correct. Now in the first expression here, p plus equal to a of b of p, we are directly calling b function, means we are assigning the value of object type. But in second and third expressions, that is these two expressions, we are passing temporary values, that is q plus is equal to b of a comma q. This means that first b function calls, then m becomes 3 here, and the value 3 we are assigning to b as a function parameter. So this is not valid. Same as the case for this also. Temporaries are only bound to constant references. So this would give a result in compilation error. So option A is the correct answer here. This is a question from C programming. We are given a C program and we are asked to assume the required header files are already included in the above program, and we are asked to predict what would be the output. This is a question from operating system. A particular parallel program computation requires 100 seconds when executed on a single processor. If 40% of this computation is inherently sequential, that is, it will not be benefit from any additional processors, then theoretically best possible elapsed times of this program running with 2 and 4 processors are, and options are given. So let's consider how to answer this. It is given that it requires 100 seconds in total. Also 40% of this computation is inherently sequential. So for this 40% of computation, how many seconds it will take? 40% can be written as 0.4 into total seconds is 100. So we'll get 40 seconds. This is inherently sequential. This anyhow it will take. Now remaining 60%, it would be 60 seconds. This 60 seconds of computation can be in parallel. So when we are using two processors, this can be done in parallel, which means that these two processors can take the load. So we can get 60 by 2, which is equal to 30 seconds each. And for 4 processors, the load can be evenly distributed among 4 processors. So we have 60 divided by 4. We have 15 seconds. So for a 2 processor, parallelly it will take 30 seconds, and sequential execution it will take 40 seconds. So 40 plus 30 equals 70 seconds. In this it will take 40 plus 15, which is equal to 55 seconds. So the correct answer is option D, 70 and 55 seconds. This is a C programming question. Consider the following C code segment and two functions are given, f and g. Of the following, which best describes the growth of f of x as a function of x? So we can write it as f of x is equal to f of x minus 1 plus g of x, and g of x can be written as f of x minus 1 plus g of x by 2. So putting value of g of n in equation 1, we can rewrite it as f of x is equal to 2 times f of x minus 1 plus g of x plus g of x by 2. So we can derive the below equation by approximation. We can say that f of x is greater than 2 times f of x minus 1. This is based on approximation, which implies that f of x is greater than 2 into 2 times f of x minus 2, because we can say that f of x is greater than 2 times f of n minus 1, then f of x minus 1 will be greater than 2 into f of n minus 2, and this goes on. So ultimately we can say that f of x is greater than 2 to the power x into f of 1. So f of x is greater than theta of 2 to the power x. So the growth for f of x is exponential, and option B is the correct answer. This is a question from computer organization. For a multiprocessor architecture, In which protocol a write transaction is forwarded to only those processors that are known to possess a copy of newly altered cache line. And based on the options, option C, directory based protocol is the correct answer. Let's see the concept of directory based protocol. In directory based cache coherence protocol, it is a cache coherence mechanism where directories are used to manage caches in place of Snoopy methods due to their scalability. For a multiprocessor architecture, in directory-based protocol, a write transaction is forwarded to only those processors that are known to possess a copy of newly altered cache line. It can be used to target both performance and scalability of the directory systems. Additionally, bus snooping methods scale poorly due to the use of broadcasting. So, directory-based protocol is the correct answer here. This is a question from algorithms. Given a binary max heap, the elements are stored in an array as 25, 14, 16, 13, 10, 8 and 12. What are the contents of the array after two delete operations? So it is already given that it is a binary max heap. So one important key point to remember is that in binary max heap, deletion is always happening at root. The steps are, first one, we delete the root, then we replace it rightmost leaf node, and again called heapify, comma heapify. This is the procedure. Now, based on the input that we are given, let's draw the binary max heap. Initially, we have 25, then we have 14, then we have 16, then we have 13, then we have 10, then we have 8, and at last 12. So, two deletes are happening. First, we delete the root, so 25. How can we delete it? So, we are deleting 25. 25 is deleted by putting 25 into the rightmost node here and bringing 12 upwards, then qualifying the heap procedure. So the first step to delete 25 is bring 12 as the root node, then the tree becomes 12, 14, 16, 13, 10 and 8. Now 25 is deleted. Again we call the heapify procedure. Heapify. We will get, we'll compare 12 with 14 and 16. So 16 is the greater value. So 16 moves up, 14 comes here, 12 comes here, 13, 10 and 8. So the heap property or max heap property is satisfied at every point. Now we again call the delete of 16. When we delete 16, we put 16 to the 8th position and we put 8 into the top. Now the root becomes 8. Then we have 14. Then we have 12, 13 and 10. Then we call the heapify procedure. Here when we heapify, we have 8 is less than 14. So 14 goes up to the top. 14 goes up to the top. Then 8 comes here temporarily. Then 12 comes up here. Then we have 13 and 10. But at this point, the heap max heap property is violated. So 13 goes up and 8 comes down. So finally we'll have 14, 13, 12, 8 and 10. This is the order. So the order will be 14, 13, 12, 8 and 10. And based on the options we have 14, 13, 12, 8, 10. And the correct answer is option C, 14, 13, 12, 8 and 10. This is a question from software engineering. The function's point metric is, and four options are given. So first of all, let's understand what is function's point. The idea behind function point metric is that size of a software product is directly dependent on the number of different functions or the features it supports. So the first point is size of software is directly proportional to number of different features or functions. The size is depend on the number of files and the number of interfaces. So a function point metric is used to calculate the complexity of the software. So going by the options, the functions point metric is calculated for software complexity assessment and option C is the correct answer here. This is a question from software engineering. The lower degree of coefficient is kind of and four options are given. So let's understand what is cohesion first of all. Cohesion is a type of ranking which is used to measure the degree of modules that are functionally related. So the degree of cohesion can be defined with the following table. Let's draw the table. On top we have functional, then we have sequential, then we have communicational, then procedural, then we have temporal, then we have logical, and last we have coincidental. And the degree of cohesion grows upwards. So this is the lowest one and this would be the topmost one. So let's explain each and every points here. First one is logical cohesion. In logical cohesion is when parts of a module are grouped because they are logically categorized. That is logical cohesion. Second one is coincidental cohesion. In coincidental cohesion is when the parts of a module are grouped arbitrarily. Third one is procedural cohesion. In procedural cohesion, it is when parts of a module are grouped because they follow a certain sequence of execution. And fourth one is communicational cohesion. In communicational cohesion, it happens if all the functions of the module refer to or update the same data structures. So these are the four types of cohesion that is explained in the option, and going by the lower degree of cohesion, we have option B, coincidental cohesion, which is the lowest one. This is a question from C programming. What is the output of the following program? We are given a C segment. We have x equal to 2 and y equal to 5. If x less than y, return x equal to x plus y, else printf z1, printf z2. Let's see what will happen. It is already given that x is equal to 2 and y is equal to 5. Now we check the condition. If x less than y, yes, 2 is less than 5. Then we return x equal to x plus 5. So x is equal to 2 plus 5, which is equal to 7. So now the value of x is set as 7 and we return. So we will not print this z1 as well as we will not print this z2. So A and B won't be coming. It is not a compilation error. So none of the options is matching. So the correct option is option D. None of this. This is a question from operating system. The operating system of a computer may periodically collect all free memory space to form contiguous block of free space. This is called. Four options are given: concatenation, garbage collection, collision, dynamic memory allocation. And the correct answer is option B, garbage collection. In garbage collection, the operating system using dynamic memory management process finds out free blocks of memory and reallocates them. There are various different techniques for garbage collection, and one such technique is mark and sweep. In mark and sweep, every object is marked and checked if it is used or not. If it is not used, then it is directly swept so that the free memory space are collected and together forms a contiguous block of free space. So option B, garbage collection, is the correct answer. This is a question from C programming. Consider the following program and we are given x is equal to 1 and we are asked to print star char star ampersand x. Assuming required header files are included and if the machine in which this program is executed is little endian, then the output will be. So the output when we execute this will create a compilation error because of this extra char. So as a result, the correct answer is not A, not B or C. The correct answer is option D. It is unpredictable. So now if this char had been removed, then the correct answer would be option C, 1. But based on the options and the current question that is given, we have the option D. It is unpredictable. This is a question from C programming. We are given two structures. First structure is named as ADDR. It has a character array named city and another character array named street, and there is an integer pin. There is another structure which is having a character array with name and an integer having name gender, and there is another data type which points towards to the initial structure and it is named with the variable locate, and there are two pointers given. One is star kd equal to ampersand person and object of it is given as person. So then star of kd of name plus 2 can be used instead of, and four options are given. First of all, let's understand what is this arrow operation in C++. It allows to access elements in structures and unions. It is used with a pointer variable pointing to the structure or union. This is the basic usage of a arrow operator. Now let's see each options one by one. Actually, option A and option B are trying to access the location, whereas option C is trying to access the value at that location, which is the third character of the name. This is what this question is also asking. So option A and B are false, whereas option C is the correct answer here. This is a question from C programming. Consider the following declaration and the structure is given with three variables. One is a character array and there is also a character array and one integer. Then another structure which is having a character array, an integer and a variable of type struct. Then one object person and another object is also given. Then we are asked to find out kd of name plus 2 followed by pointer. So the first two options, it points to the address of the location, whereas we are required to access the value at the location, which is the third character of the name. This is a question from digital logic design. If a variable can take only integral values from 0 to n, where n is an integer, then the variable can be represented as a bit field whose width is the log in the answers are to the base 2 and log n means floor of log n, and we are given four options. So actually log 0 is infinity here. So log 0 is infinity, but 0 can be represented using 1 bit. So as a result, both option A and option B are eliminated because we are having only 1 bit to represent. So log of 0 is infinity. So this cannot be represented. Also this cannot be represented. Now option C, take n is equal to 3 now. So it will give log of 4, which means 2 plus 1. So 3 bits to represent numbers in the range from 0 to 3. But to represent 3, we need only 2 bits. So option C is also not correct. So the correct answer is option D, none of the above. This is a question from operating system. We are given a C program and it calls for 2 times and printf statement. If we execute this code statement, how many times the string yes will be printed? So the first point to note is that fork is a system call which can create new processes, or also called as child process. So assume this is the process P1 and it has a code base fork, fork, and yes is printed. Now this statement is executed. When this statement is executed, it creates a new child process with the next line of execution from this point. That is from this point. So here we'll have one fork, then yes. Now this would create another child process. This would be P2 and let this be P3. This would print yes. So when we print this yes, one time it is executed. Now this goes back and we print yes here. So one more time it is executed. Now we go back. Now this fork gets executed. So this creates another process P4 with yes here. So one more time this gets executed. Now we go back here and we just print this yes. So one more time is getting executed. So which is 4 times. So the correct answer is option C, 4 times. So one important formula is if there are n fork statements, fork statements, then 2 to the power of n total process is created. This is an important point. This is a question from digital logic design. We are given square root of 224 to the base r is equal to 13 to the base r, and we are asked to find out the value of radix r. So first square both sides. We will get 224 base r is equal to 13 base r the whole square. So we can rewrite it as 2r square plus 2r plus 4 is equal to r plus 3 the whole square. So we can again rewrite it as 2r square plus 2r plus 4 is equal to r square plus 9 plus 6r. So we have r square minus 4r minus 5 is equal to 0. So the roots will be r is equal to either 5 or minus 1. Minus 1 cannot be possible because radix cannot be negative. So r equal to 5 is the correct answer and option D is the correct answer in this. This is a question from operating system. Determine the number of page faults when reference to the page occur in this order, that is 1, 2, 4, 5, 2, 1, 2, 4. Assume that the main memory can accommodate only 3 pages. So the main memory can accommodate only 3 pages, 1, 2 and 3. And the main memory has already bought in pages 1 and 2. And 1 is bought earlier than 2. We are using LRU based algorithm. So now when we check for this page 1, it is already in memory. So it is a hit. In page 2, it is already a hit. Page 4, it is a miss. So it is bought here. So one page fault has occurred. Now when we search for page 5, we cannot find it in memory. So this is also a page fault. Now one page has to be replaced from the memory. So least recently used. So we trace back. 4 is not recently used. 2 is next recently used and 1 is the least recently used. So we remove 1 from the memory and we place 5 here. Now we check for 2. 2 is already in the main memory. Now we check for 1. So 1 is not in the main memory. So we trace back. The least recent is 2 is not, 5 is not, 4. So 4 is being replaced by 1 here. Next 2 is also a hit. Now when we check for 4, 4 is not here. So this also causes a page fault. So the total number of page faults are 1, 2, 3 and 4. So the correct answer is option B, 4. This is the correct answer. This is a question from operating system. Consider a system having m resources of the same type. These resources are shared by three processes, namely A, B, and C, which have peak time demands of 3, 4, and 6 respectively. The minimum value of M that ensures deadlock will never occur is, and four options are given. So let the resources needed by A, B, and C be noted as, let resources by A equal to R1 equal to 3, by B equal to R2 equal to 4, by C equal to R3 equal to 6. So minimum resources, minimum number of resources to ensure no deadlock is equal to R1 minus 1 plus R2 minus 1 plus R3 minus 1 plus 1, which is equal to 2 plus 4, 2 plus not 4, 2 plus 3, 2 plus 3 plus 5 plus 1, which is equal to 11. So the correct option is option A, 11. Why this is happening? Because we are assigning, let the resources be denoted as dots. So for A we are assigning 2 resources. For B we are giving 3 resources. For C we are giving 1, 2, 3, 4 and 5. These are these 3 values. Now we are assigning one more extra resource. In this case, deadlock is bound to occur. So this is the maximum value which deadlock can occur. Now if you are assigning one more resource to this, so either A or B or C can now execute. After that execution, it can relieve its resources, then the next process can execute, then it can relieve its resources, then the next process can execute. So the minimum number can be calculated using this formula. And correct answer is option A. This is a question from operating system. A computer has 1000K of main memory. The jobs arrive and finish in the sequence. Job 1 requires 200K. Job 2 requires 350K. Job 3 requires 300K. Now job 1 finishes. Then job 4 requires 120K. Job 5 requires 150K. And job 6 requires 80K. Among best fit and first fit, which performs better? So what is first fit and best fit? In first fit, we try to allocate memory to a process which happens in such a way that whichever block is occurring first that can accommodate that process, that will be assigned, and this happens during a sequential search. Whereas in best fit, what happens is the smallest memory block which can be allocated to that process, that is chosen. So this is the major difference. In first fit, while sequentially searching, whichever block is okay to accept that particular process, we assign that block first. Whereas in best fit, the smallest available block which can accommodate that process will be allocated. Now let's see the job sequence and draw the diagram. So initially we have a 1000K of main memory. So in both best fit and first fit, job 1 arrives. So we are able to allocate 200K here, 200 here. Job 2 arrives. So to 350K. So we have 550 in total. And job 3 arrives. We can associate 850. Okay. So remaining we have remaining 150K of main memory. So in both cases for best fit and first fit, this scenario is similar. Now let's assume first fit is happening. As job 1 finishes, the current memory status would be like this. This 200K would be free. And job 2, 550. And job 3, it is 850. Now we have free 150K as well as 200K memories. Now in first fit, job 4 arrives. It requires 120K. This block is the first block which can allocate this 120K requirement. So job 4 is placed here. Now till 120 we have. So here we have 80K of free space. Now job 5 arrives. So this 80K is not sufficient, but job 6 can be allocated. Job 5 can be allocated in the last 150 block. So job 5 is allocated here. Now we have just 80K free memory. Job 6 arrives and this job 6 is allocated here. So first fit can allocate all the requirements. Now moving on to best fit. In best fit, the current scenario is we have 200k of free memory here, J2 is here, and J3 is here. Now we have 200k as well as 150k. Now job 4, which requires 120k, arrives. So it is assigned to which block, this 200 block or 150 block. So 150 block is the smallest block which can allocate this job 4. So job 4 is allocated here. So what happens here is job 4 gets allocated here, and out of this 200, job 4 gets allocated here, and now out of 150 we have 30k free memory. Now job 5 arrives. It requires 150k. Among this 150k, only 200k can be allocated to that block. So this job 5 is allocated here. Now 80k block requirement comes. The available free memory is 50k and 30k. So this 80k cannot be allocated. So first fit fails. So best fit fails here. So first fit only works. So the correct option is option A, first fit. This is a question from operating system. Disk requests come to the disk driver for cylinders in the order 10, 22, 20, 2, 40, 6, and 38 at a time when the disk drive is reading from the cylinder 20. The seek time is 6 milliseconds per cylinder. The total seek time if the disk arm scheduling algorithm is first come first served. So first of all, let's write the disk request order 10, 20, it's actually 22, 10, 22, 20, then we have 2, 40, 6, and 38. The disk is currently reading from the cylinder 20, current position. Now how to calculate? So since it is first come first served, it is simply serving in this particular order. So we can calculate it as initially the cylinder is at 20. So to reach 10, we require 10 moves. So 20 minus 10. Now it is at 10. To reach 22, it requires 22 minus 10. Now it is at 22. To reach 20, it requires 22 minus 20. Now at 20, it requires to reach 2. So 20 minus 2. Now at 2, it is required to move to 40. So 40 minus 2. Now at 40, it is required to move to 6. So 40 minus 6. At 6, it is required to move to 38. So 38 minus 6. So in total, we have 10 plus 12 plus 20 plus 38 plus 34 plus 32, which is equal to 146 moves. And each the seek time is 6 milliseconds per cylinder. So we have 146 into 6, which is equal to 876 milliseconds. So none of the options matches in this. So option D is the correct answer. This is a question from data structures. A hash table with 10 buckets with one slot per bucket is shown in the following figure. The symbols S1 to S7 initially entered using a hashing function with linear probing. The maximum number of comparisons needed in searching an item that is not present is. So first of all, what is linear probing? In linear probing, the hash table is searched sequentially that starts from the origin location of the hash. If in case the location that we get is already occupied, then we check for the next available location. This is the concept of linear probing. So other than that, the maximum number of comparisons needed to search for an element that is not present is equal to maximum cluster size plus 1. And what is the maximum cluster size? In maximum cluster size, here it is 4. This is because this 8, 9 and 0 and 1, these together forms a single cluster. So the maximum cluster size is 4 plus 1, which is equal to 5, is the maximum number of comparisons needed in searching for an item that is not present. So the correct answer is option B, 5. Let's explain for it. Suppose we are starting the searching from here. Now when we search here, it is not available here. Then it is not available here. It is not available here. It is not available here. Then in this position only we will be able to find that the item that we are searching is not present. So correct answer is option 5. This is a question from algorithms. The running time complexity of an algorithm is given by T of n equal to T of n minus 1 plus T of n minus 2 minus T of n minus 3 for n greater than 3, or it is equal to n otherwise. Then what should be the relation between T of 1, T of 2 and T of 3 so that the order of the algorithm is constant? So for sufficiently larger values of n, we can say that T of n is equal to T of n minus 1 plus T of n minus 2 minus T of n minus 3. T of n minus 3. We can say like this. If the order of the algorithm for which the above recurrence is applicable for the time complexity is a constant, then we can say that T of n is equal to T of n minus 1. So rewriting, we can say that T of n is equal to T of n plus T of n minus 2 minus T of n minus 3. Now going forward, we can say that similarly T of n minus 2 is equal to T of n minus 3. So going like this, we must have T of 1 is equal to T of 2 is equal to T of 3. This is option A. So the correct answer in this question is option A, T of 1 equal to T of 2 equal to T of 3 for the algorithm to be a constant. This is a question from graph theory. The number of edges in a regular graph of degree d and n vertices are, and 4 options are given. So what is a regular graph of degree d? A regular graph of degree d has all vertices which is having degree d. This is the formula. So given data is degree is equal to d and vertices is equal to n. These are the numbers. By handshaking lemma, we can write that sum of degree of all the vertices, sum of degree of all vertices is equal to 2 times the number of edges. 2 times the number of edges. So for a regular graph, all degrees are d and sum of all degrees would be number of vertices into degree of each vertices is equal to 2 into e. So the number of edges, this is equal to n into d by 2. So option D, nd by 2 is the correct answer. This is a question from computer graphics. We are asked to perform window to viewport transformation for the point 20, 15. Assume that xw min and yw min are 0, 0, xw max and yw max is 100, 100, xv min yv min is 5, 5, xv max yv max is equal to 20, 20. The value of x and y in viewport is. So the formula to calculate the value of x and y in viewport is as follows. So xv in viewport is equal to xv minus xv min divided by xv max minus xv min. This is equal to xw minus xw min by xw max minus xw min. This is the formula for calculating x coordinate. And for similarly y coordinate, we have yv is equal to yv minus yv min divided by yv max minus yv min is equal to YW minus YW min divided by YW max minus YW min. This is the formula. So now let's calculate. And the important points that are given here is X W min comma Y W min is equal to 0 comma 0. Then XW comma YW is equal to 20 comma 15. And the next point is XW max comma YW max is equal to 100 comma 100. Then we have XV min comma YV min is equal to 5 comma 5. And finally we have XW max comma YW max is equal to 20 comma 20. Now substituting these values in these two formulas, we will get the final result as 8 comma 7.25. So the correct option is option C, X equal to 8 and Y equal to 7.25. This is a question from databases. Given the relation R, W, X are attributes and S, Y, Z are attributes, the result of select distinct of W, X from R, S is guaranteed to be same as R, and 4 options are given. One important point to note is that in SQL, relations are multi-set. So duplicates are allowed. This is an important point. Now moving on to each of the options. Option A, R has no duplicates and S is non-empty. So assume that R has duplicates. In that case, due to the distinct keyword, those duplicates will be eliminated from the final result. So we will not get the same as R. So here it is mentioned that R has no duplicates and S is non-empty. So if S is empty, then R cross S will also become empty. But here S is non-empty. So this can give the result as same as R. So option A is a correct option. Now moving on to option B. R and S has no duplicates. Here assume that S is empty. In that case also S is having no duplicates. So R cross S will be empty here. So it is not guaranteed to be same as R. So this option is false. Let's see option C. S has no duplicates and R is non-empty. The above argument for option B can be used here also. Assume that S is empty. So R cross S will be empty. So it will not be same as R. And option D, R and S has same number of tuples. Assume that R has duplicates. Then in that case, due to the distinct keyword, the duplicates will be removed. So the result of the query will not be equal to R. So this option is also false. So only option A is the correct and B, C and D are wrong. This is a question from databases. Immunity of the external schemas or application program to changes in the conceptual schema is referred to as, and 4 options are given. So first of all, what is immunity? Immunity here means that if we make certain changes in the one level of database design, it will not affect the other part of the database design. That is immunity. Now what is physical data independence? If we make any change in the physical storage of the schema, it will not affect the logical schema or the conceptual schema. And what is logical data independence? If you make any conceptual change, it will not affect the external schema or end software using this database. So based on the question and the options given, option B, logical data independence is the correct answer here. This is a question from databases. The set of attributes X will be fully functionally dependent on the set of attributes Y if the following conditions are satisfied. So we can say that x implies y means that if x is same, then y is also same. This is the meaning of x implies y. So some of the rules that are associated with the dependencies of x implies y are reflexive. It means that if x is a set of attributes and y is a subset of x, then x holds a value of y. This is reflexive rule. Now in augmentation rule, that is another rule, augmentation. Here if x implies y holds and C is an attribute set, then xc implies yc also holds due to the augmentation rule. Now the criteria for fully functional dependency is that an attribute x is said to be fully functionally dependent on attribute y if x is functionally dependent on y and not on any of its proper subsets. So based on this definition, we can say that option A is correct, also option B is correct. So in option C, it is given that both A and B are correct. So the correct answer is option C, both A and B. This is a question from databases. Let us assume that the transaction T1 has arrived before transaction T2. Consider the schedule S equal to read of A, read of B, the write of A and write of B. Which of the following is true, and 4 options are given. Based on the schedule, let's draw the transaction. This is the transaction table. We have two transactions T1 and T2. We have initially R1 of A, so it is read of A. Next is R2 of B, so this is read of B. Next we have W2 of A, so this is write of A. Next we have write of B. So there are two conflicting operations. One is this and this. These are the two. In basic timestamp ordering protocol, the conflicting operations should be executed in the timestamping order, else we have to roll back. So in this, T2 performs read of B, this operation. Then its timestamp will be newer, and when older transaction performs write on B, that is T1 performs write on B, the timestamp ordering protocol's condition is violated. So what happens here is that it is not allowed under basic timestamp protocol because now T1 has to roll back because of the violated condition. So T1 roll backs as a result of the violation of basic timestamping protocol rule. So option B, not allowed under basic timestamp protocol because T1 is rolled back, is the correct answer here. This is a question from algorithms, and moreover the question is like a memory based question. The time complexity of computing the transitive closure of binary relation on a set of n elements is known to be, and 4 options are given. The transitive closure of binary relation on a set of n elements can be found out using Floyd-Warshall algorithm. Floyd-Warshall algorithm. And the time complexity for computing the transitive closure using Floyd-Warshall algorithm is order of n to the power 3. So here we need to remember that this mapping, that is transitive closure of binary relation on a set of n elements, can be calculated using Floyd-Warshall algorithm, and the complexity of Floyd-Warshall algorithm is order of n to the power 3. So option D, order of n to the power 3, is the correct answer. This is a question from operating system. In multi-programmed system, it is advantageous if some programs such as editors and compilers can be shared by several users. Which of the following must be true of multi-program systems in order that a single copy of a program can be shared by several users? And the options are: the program is macro, the program is recursive, the program is re-entrant. So the correct answer is option C, that is 3 only. The program is re-entrant. This is because re-entrant code is commonly required in operating systems and in applications intended to be shared in multi-user systems. So this question is also asking regarding the same. So let's understand a bit about what is re-entrant code. In re-entrant code, the programmer writes a re-entrant program by making sure that no instructions modify the contents of variable values in each other's instruction within the program. So each time the program is entered for a particular user, a data area is obtained which keeps all the variable values for that particular user. So a particular area in the main memory, suppose this is the main memory, for each user a particular area in the main memory would be fixed when each particular user logs in, and all the data pertaining to that particular variable values would be stored here. So as a result, we can make sure that no important variable values are being modified by another user. So this is why re-entrant code is used in multi-user operating systems. So option C is the correct answer. This is a question from C programming. We are given a code where a float variables are declared as sum equal to 0.0, j equal to 1, I equal to 2, while I by j greater than 0.001, j equal to j plus 1, sum is equal to sum plus I by j, and we are printing sum. How many lines of output does this program produce? This is the question. So the while loop runs till I by j is equal to 0.001. So we can rewrite it as I by j is equal to 1 by 1000. Now I into 1000 is equal to j. We can rewrite it as follows. So here I is equal to 2. So j is equal to 2000. So while loop runs till j is equal to 2000. So the output will have more or less than 2000 lines. So option D, more than 29 lines of output, is the correct answer here. This is a question from C programming. We are given a C code and we are asked to find out the number of lines of output this program produces. The major condition given here is that while I by j greater than 0.001. So I by j greater than 0.001. We can write it as this loop runs till I by j becomes equal to 0.001. So ideally thinking 0.001 is equal to 1 by 1000. So we can say that I by j is greater than 1 by 1000. We can rewrite the equality as I by j is equal to 1 by 1000. This is an approximation which implies I is equal to 2 given here, j is equal to 1 initially. So 2 by j is equal to 1 by 1000, which implies j is equal to 2000. So the while loop runs till j becomes equal to 2000. So the number of output it produces will be having more or less than 1999 lines of output. So option D, more than 29 lines of output, is the correct answer here. This is a question from C programming. An array A consists of n integers in locations A0, A1 till an-1. It is required to shift the elements of the array cyclically to the left by k places, where 1 less than or equal to k less than or equal to n-1. An incomplete algorithm for doing this in linear time without using another array is given below. Complete the algorithm by filling the blanks. Assume all variables are suitably declared. And we are given 4 options. So in each options, the last 2 statements are remaining the same. That is temp and I plus 1. So we suitably fill it as temp, comma, I plus 1. Now let's see what should be the first blank to be filled. It is given I greater than min or I less than min. So here I is equal to 0, and if n is equal to 5, assume. So min is also equal to 5. Now if I greater than min is the condition, so 0 greater than 5, this condition is false. So the while loop will not be entered at any time. So we will not be entering into this loop at all. So this condition I greater than min is not correct. So suitably I less than min should be the first statement here. So going by that, option A is wrong, as well as option C is wrong. We can write here I less than min. Now we have two options, option B or option D. Now let's see option B and assume it as correct, and let's fill the values. In option B, the next statement that is to be filled here is j not equal to n plus I mod n. That means that whenever j becomes equal to n plus I mod n, then control goes out of the while loop. Suppose now n plus I mod n equal to I, and j is always equal to I, because in line 3 of the code we are assigning the value of I to j. So if option B is true, control never enters the second while loop, but it has to enter the second while loop to shift the number by places left. So as a result, option B also cannot be the right answer. So finally we have option D, which is the correct answer here.